Okay, here we are at SatBBC testing a full Earth station that we will be shipping sometime next week. Here's a breakdown of the components that we are using. We're actually going to take you down the path that each of our test bits are following through our satellite system. Please notice the Fireberd 6000 is what is generating our bits. Fireberd 6000 feeds our modulator. Our modulator takes the data from the 6000, modulates it onto a 70 megahertz carrier. 70 megahertz carrier then comes into our C-band upconverter. C-band upconverter, upconverting our signal to 6.15 gigahertz. 6.15 gigahertz coming out, feeding our TWTAs. These are 400 watt MCL TWTAs, older units, low hours, very low helix current, which we'll show you briefly. Out of the TWT into a cross-guide coupler and dumbing load. Cross-guide coupler is there to give us a sample port that has a workable, usable amount of power for our testing purposes without the health hazards. Cross-guide coupler is feeding into our satellite simulator. Satellite simulator is translating our frequency by 2.3 gigahertz, 2.225 gigahertz for C-band. 2.3 is Ku-band. Yeah, we're doing C-band, so again, does our translation, knocks our signal down to our 3.925 gigahertz. So we're coming out of the simulator, going into a transition with attenuation, feeding into our transmit reject filter, feeding into our LNA. LNA is being powered by a power supply that we will be providing to the customer. We're using a bias T for that. Out of the bias T, we're feeding into the downconverter. Downconverter is downconverting the signal back to the 70 megahertz level, which is then feeding our demodulator. Demodulator is taking that original bit that we sent out in the beginning and sending it to the Fireberd. The Fireberd likes it, as you can see by the green sync light. And no sync losses, no bit errors showing.